So good afternoon, everyone. Welcome back to Math 122. Today we're going to be talking over sections 1.4 and 1.5. We might touch a little bit on 1.6, depending on how quickly we make it through things. As always, I'll remind you about your homework and assessment. So homework, you have 1.3 is due tonight at 11:59 p.m. 1.4 is due Thursday. Okay, so quiz 2 is also going to be this Thursday, but because 1.4 homework is not due before that quiz, it won't be on the quiz. Okay, so the quiz will be always on those homeworks which have had due dates between our last quiz and the next quiz. Okay, so that'll be sections 1.2 and 1.3 for the quiz this Thursday. So similar deal to what we did last week. At the end of class, I'll give you a couple questions. Ideally, you won't really feel pressured for time, especially not if you prepare, which you can do easily by practicing the problems from these two homework assignments, because I will draw the quiz problems from those homework assignments word for word. I'll make the numbers nice so that they work out, and you don't need a calculator. So that's homework and quiz. Regarding my office hours, 11:30 to 1 on Thursday. I got my math tutoring center assignment, sorry, not 11:30 to 1. 11:30 to 1 on Thursday. On Tuesday, I'm in the math tutoring center from 10 to 12, and then in my office from 12 to 1. And then I'll probably add an hour on, I think I said it would be Wednesday afternoon or something like that, something like a 3 p.m. Why don't we say this week it'll be Wednesday, 3 to 4 in 439. That's my office. Okay, so that'll be for those of you who can't make it to my other office hours. If you can't make it to any of those, the first line of defense, I would say go to the Math Tutoring Center during a time that works for you. There will be another graduate student in there who's probably taught this class before, or else already has a degree in math at least, so they'll be able to help you. Other than that, you can also schedule an appointment with me if you really need to see me. Then just email me and let me know what's your availability so that I can sort of choose a time in there that works for me. So that's all I have to say about the title screen. Any administrative comments, questions, or concerns before we start in on content for today? Yeah.
You're going to give us those quizzes back?
Yeah, I already passed them out, but come and get them after class if you didn't get it already. They should be all in Blackboard, so check your grades on Blackboard, make sure they line up with what you see on your paper. Yeah, any other questions?
Is the quiz 1.2 and 1.3?
Yeah. So the quiz will be 2 problems. I'll probably choose 1 problem from the homework 1.2 and 1 problem from the homework 1.3. Or if it's really small, maybe I'll choose 2 or something like that. But basically same type of format as last week. Any other questions? All right. Then let me remind you what we were talking about last time, and then we'll get to work on today's material. So, yes, if I'm not mistaken, last time we talked about average rate of change. Okay, so average rate of change was to sort of describe the slope of a function over a given interval. Okay, so the interval is the x values. To describe the average slope, okay, or average rate of change of this curvy bit, we can say, well, on average, it's going to be equal to the slope of this line. So what does that mean? Well, it just means that, you can change in this kind of wonky way, increasing faster and faster and slower, decreasing a little bit, has the same net effect as if you were just changing at a constant rate from left to right at this particular constant rate. Okay, so that was average rate of change. We did some examples with that. And then we did average velocity, which of course velocity is just the rate of change or the slope of a distance function or a position function. That's what we were talking about a little bit before class. So that was simply given by plugging in the distance function for our average rate of change. Okay, so again, the super simple example we had regarding that was, look, you can drive 30 miles an hour for an hour and then 10 miles an hour for an hour, or you can drive 20 miles an hour for 2 hours, right? Both are going to get you the same result in terms of total distance traveled, right? Which is measured by this distance here. Okay, so that was average rate of change. And then, oh yes, we had relative change, okay? So new quantity minus the original quantity, divide by the original quantity. That's how you get the relative change in x. So, okay, in terms of like percent off or percent markup, if you're talking about change in price, or percent growth of your YouTube channel or whatever. By the way, I just hit 100 subscribers on YouTube channel. So I don't know. I feel like I deserve some kind of play button, but it needs to be like a really low quality substance because I know, yeah, like a dirt play button. Cardboard. Yes, cardboard. Okay, here we go. Now we're getting somewhere. Okay, anyways, I thought that was hilarious because they sent me an email this morning. I was like, oh, now I've made it. 100 subscribers. All right, well, anyways, I don't really do YouTube for the subscribers. I just do it so that you all can watch the lectures. If you have a day where you can't make it to class or whatever, you can go watch the lecture and you know, receive essentially the same instruction that you would in here minus the group work. So that's what you should do if you ever miss a class. Just go watch the video on YouTube. Or if you are studying for a exam and you can't remember how to do something, you know, find out what section that's from and go back to the YouTube video where we had our class on that section, and you can study using those as well. Anyways, so that's relative change. I can't believe you all applauded my 100 subscribers. Thank you. Okay, so then we talked about concavity, which concavity was just about the shape of the graph, okay? So loosely speaking, if we're bending upwards, okay, as does the letter U, then we are concave up. And if you're bending downwards, okay, then it's like the letter N in the word concave down. Okay, and then you can also sort of break this up in terms of whether you are increasing or decreasing. So top left, we are increasing in concave up, and then we are decreasing in concave up here. On the bottom, we are increasing in concave down, and then here we are decreasing in concave down. So those are the 4 possibilities for a graph. So one comment I want to make about concavity is it's telling you about the rate of change of the function. Initially, the slope of this function is quite steep, and it's becoming, it starts out negative and it becomes more and more positive. Okay, so the rate of change is changing from left to right. It starts out as a negative, and then it's like more 0, and then it's like positive. So the rate of change of our function is increasing. Okay, so the rate of change itself is changing, right? For concave down, we see the opposite thing happening. The rate of change is decreasing from left to right. First we're positive, then we're 0, then we're negative. Okay, so this is how you can tell whether something is concave down. I thought there was an example in here somewhere. Is it up here? No, I was looking for, I know it's somewhere in these notes. There's an example of trying to figure out from a table whether a function is concave up or down. Okay, I'll just have to recreate this. Jeez, where was I? Okay, so let's see quickly an example of how to tell whether a function is concave down or concave up if you don't have a graph. Then what are you supposed to do? Okay, well, let's see something like this. I'm going to make a table of inputs and outputs. The inputs, x, are going to go 0, 1, 2, 3, 4, and 5. And the outputs are going to go 10, 11, 12, 16, 25, and 49. Okay, and our goal is to determine whether this function is concave up or concave down. Well, there's two things you can do. The first thing you can do is to plot these points. If you want, you can do that. So as we go left to right, we go 0, 1, 2, 3, 4, 5, whatever. The point heights are like 10, and then 11's not much higher than 10, and then 12 isn't much higher than that. But then we start jumping, right? We start going up to, oops, these should go to the left a little bit, shouldn't they? There we go. Something like this. And then the points go up faster and faster, right? Well, if you look at a picture of a graph that looks kind of like this, it looks concave up. So you can see based on graphing points, but also you can just look at the numbers. Look, the numbers start going up by little, but then the rate at which we are increasing itself increases, okay? Which is to say that we're going up a little bit, going up a little bit, going up medium, going up medium, going up a lot. This is to say that our rate of change is going like something like this. Yeah? Which looks something like a concave up. Right? Okay. That's the basic idea. Okay, so then we talked about cost, revenue, and well, okay. Any questions on concavity or average rate of change? Okay. Well, then we started talking about economics, because this is, after all, business calc, so we should talk about business. So regarding that, we discussed cost, revenue, and profit functions. Okay, so cost is the input is going to be the number of units that you are producing. Okay, so however many t-shirts you are making, or however many whatever, okay, whatever thing that you're selling, okay, it costs you something to produce it. Typically, if nothing else, then it requires the cost of manpower, right? Or woman power, could be any kind of power. Anyways, so the revenue then is going to be what you take from the customer for that good or service, right? For that good or service. And then if you take the money that you get from the customer minus what you paid for the materials of the good that you produced, or for the work that you paid your employees or whatever, then you get your total profit, right? So profit, we use the symbol pi. Pi goes with P, goes with the word profit. I don't know why they use the Greek letter pi, but they do. Okay, and for now, we're just treating these as linear functions, but we're going to think of more complicated cost, revenue, and profit functions later on. Okay, so the first example we saw there was to discuss the difference between fixed costs and variable costs. Okay, fixed costs are just whatever you have to pay one time to get yourself off the ground. And then the variable cost is going to be like the cost per item that you sell. Okay? Then finally, we talked about marginal revenue, marginal cost, and marginal profit, which are just the rate of change of these functions. Okay, so later on we're going to think about revenue functions that might be curvy. Okay, and we're going to be thinking about the way that they're changing. But for now we're just thinking about lines, and the rate of change of a line is perfectly described by its slope. Okay, so the marginal slope, or marginal revenue, is just the slope of the revenue function. Marginal cost is the slope of the cost function. Marginal profit is the slope of the profit function. And the final thing that I wanted to say here, this is something new, is that the other way that they just like to describe marginal profit and marginals or whatever in the textbook and in your homework is it's the increase in cost or increase in revenue or increase in profit associated with producing one more item. Okay, so sometimes we'll talk about the marginal cost at 500 units. When I say marginal cost at 500 units, what I mean is what is going to be the associated increase in cost to me, the supplier, in order to produce the 501st unit, okay? Which, of course, if we increase the unit by 1 on a line, if we increase the independent variable by 1, the dependent variable is going to go up by how much? If I have y equals mx plus b, okay, what's the difference between this and this? Well, we can see it by subtracting, right? We can take, when I say what's the difference, I mean that literally. M times x plus 1 plus b minus m times x plus b. Cancel, 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 cancel. What am I left with? Of course, the one's inside those parentheses, right? So we got to distribute, so we get m. That's the whole deal with the slope of a line. The slope tells you if you go over 1, you go up by m. The slope, right? That's what the slope says. Over 1, up by m. Yeah? All right. So that's marginal cost. For break-even quantity, okay, well, let me ask you all. What does it mean if I, as a business person, break even? Yeah, Owen?
Your cost equal your revenue.
Yeah, cost equal your revenue. So if revenue is equal to cost, what's my profit? 0, right? If your revenue is equal to your costs, okay, and why don't we make this a specific quantity like Q naught, Q naught, Q naught, okay? So to say that this is a specific quantity of goods that I can produce that causes my revenue to be equal to my cost when I plug in that quantity into each of the respective revenue and cost functions, then if I take that and plug into pi of Q, well, I know that pi of Q naught is just going to be R of Q naught minus C of Q naught. And I know that these two numbers are the same. If I subtract something from itself, I get 0. So the break-even quantity is the quantity of goods necessary to produce 0 profit. Another way of thinking about that would be to say, if this is my profit function, a lot of profit functions look something like this. Okay? A lot of profit functions look like this. What's the story of this profit function? Can somebody put it into like a 1-sentence story for me? Of what this graph represents in terms of my business. Say I'm selling t-shirts. This is kind of like that quiz problem that we had, right? We want to be able to look at these graphs and tell a story about what it means in terms of the problem, right? Yeah.
You went into debt.
Yeah, initially, my profit is negative. Braden, you want to finish up?
And then as he began to sell his product, he began to earn money. And broke even, then began to earn more revenue.
Exactly. So just a tiny bit more of the story there is to say, look, yes, initially we go into debt to start our business. That makes a lot of sense, right? You go into debt, and then you sell, and you sell, and you sell, and you sell, and then there comes a point where you have sold enough items to have balanced out your investment. And then from there, it's just, you're in the green, right? Make sense? Okay. Thanks. And that's Braden, and you're Ryan? You're not Ryan. You're
Starts with a D. It's like what's culminated.
Daniel. Yeah, you're one of the Daniels. Okay. All right. Anyways, so that's the break-even quantity. The break-even quantity could also be rephrased as the horizontal intercept of the profit function. It's the quantity Q which causes the height of the profit function to be a 0. All right, cool. So that's the break-even quantity. All right, so what I want to do now is launch into a group work, okay? So we're going to try, how many does this have? Okay, it's got A through E. So quite a lot to bite off here. Ted's running some kind of lawn care business. So we want to work on finding these revenue, cost, profit functions. And then after that, okay, we're going to discuss what is the marginal profit. And finally, what is the break-even quantity. So you get to do this hands-on. I'll be walking around to help. Please work with a partner. And yeah, just raise your hand if you want some individual attention. Feel free to work in groups of 3 if you want, but I wouldn't go much larger than that.
It's 4x plus 2.
And really quickly, can I ask everybody to put their backpacks like in front of them under the thing, just so that I can walk through? It's a little easier for me to get to all the groups that way. Thank you.
Oh, wait, no. So that's just right.
Remember Marshall?
54. So I think a good place to start revenue is if we just read
Wait,
through the thing.
I thought the $4 would be on the cost, right? With like gas and maintenance.
So then you could just say he's making 46 base charging 50.
And then I could do like.
Is that a one-time cost or a recurring?
No, just do.
So that would be.
True. How about the next one? Equal an average of $4 per job for gas. Is that cost or revenue?
And then $50 is what you charge.
That's more cost, right? So that is just fixed cost, one-time payment, or is it a recurring payment? So it's a variable cost. So fixed cost plus our variable cost is so our cost is a function of how many.
If I use like the monkey brain method, it should just be.
So
It should just be $46 a job. It's the easiest kind of thing. If you're spending $4 on gas and maintenance per job as well.
Yeah, I just put that with so I guess you just keep it. But like.
Well, that's not cost.
It
like
is
the
cost.
variable-
Because he
Oh,
has
you
it.
mean before?
Yeah, it says it would cost him 12,000, so that's the 4,000.
what was my total cost?
Yeah, but that's $4. Oh, okay. Oh, I know.
Like it'd be like 12,000 plus Q. And the RQ is 50. I
We have to pay our $12,000. So we're gonna run.
Well, I get that cost, but like,
And then we're gonna add that.
marginal cost would be
That was hard.
Wow, my handwriting is extra bad today.
Oh, I'm really bad at this.
Well, it's gonna be Q. Q is the variable that represents like how much off is Yeah, but we always use Q to represent
So
like
it's,
the transfer. Yeah, well.
So you can just, I mean, if it wants like a,
Cost Q is.
I'm just gonna make a formula out of the formulas.
That's not, we're just subtracting the inputs now. Subtracting the negatives. Later on, when we do profit function, profit function is added on the revenue function minus the cost function. Okay, so when we do this, all that cost is gonna be on there. Okay, how about the revenue function? What should that describe? Well, hang on. This is just the cost function. So this is just the price Q.
So the P54 Q
So
is 12,000.
is gonna represent what? That's how much we charge.
No, this one
Oh, regular profit? No, regular profit, you just gotta slap them together for these like the equations that we just made together. Like,
So like if you simplify it,
oh, well,
Hey, we're getting that can
I
be
mean,
part of our cost.
I didn't really, I didn't see a reason to simplify it when the equations are already going separate entities. I just,
Q long, but we make it 50.
it would be 40.
So our revenue.
Yeah.
So how about? Yeah.
marginal profit.
Right now, we're gonna.
46.
Goddamn.
On revenue, minus our cost.
We buy a feature, like I don't know what this means.
Crikey.
Oh, so we just said it.
Good.
No, you want 46 Q equal
Fine.
to 12,000.
Yeah.
You
just
said
said-
oh.
You said like the profit equals
Oh,
zero.
okay.
You know what I mean? I don't know what 12,000 You round up or down?
So it's asking how many jobs, so
Yeah,
it's,
so down.
yeah. 200 what?
160.
Right, so
261.
I think we did that right.
the height of this
I don't feel like redoing it.
describes how much money we
Hell
make
yeah.
by selling a
Verification.
certain number of units. So this would be like 0, 0, that would represent $0 for 0 units, right? But initially, what do we have? We don't have 0, 0, we have 0 and then something negative, right? Which is to say, look, if I sell 0 items, I've actually lost money. Then I sell item after item after item after item. Each item that I sell, I make a little money, I make a little money, I make a little money, okay? And then, if I sell enough, I make enough money that I've offset my income. So this distance here is kind of like a, let's say I, make a lemonade stand or something like that. I gotta buy a lemonade stand, it costs me $1,000. And then I make like $1 per cup of lemonade, $1 per cup of lemonade. And after I've sold 1,000 cups of lemonade, then I'll have made $1,000, which is enough to offset my initial investment.
I'm so tired.
Exhausted.
I
Why?
woke up like, I went to sleep at like 1, woke up at 9 to go to the gym with my friends. Like, back.
I literally, well, okay, well, I'm like half funny, and I went to bed at like 11, like super early, and then was up at 3:50. Couldn't fall back to sleep. I literally had to sleep, so I went and slept in the kitchen. Like I literally just could not fall back to sleep. I was like, okay.
How many
I need to
lemons?
go.
Went on like the
So,
couch or like.
yeah, on the couch in the kitchen,
One
and just
here,
slept
somewhere
there.
along here.
So like I just did not
So
really
let's say,
actually.
this is 1,000 lemonade sold, this is 2,000 lemonade sold. if I sell 1,000
Like,
lemonades.
that's my second time, I think. Maybe
Okay, so
third.
you tell me the amount of lemonade,
I slept
and I'll tell you how much money I did. If you tell me I sold 500 lemonades, I'll say I'm still $500.
Same
You tell me,
my
okay,
one
you sold
friend
400
brought it
lemonades, then I'll say, okay,
heard all
there you
that.
go.
And
You tell me that you sold 18,000 lemonades, I'll tell you what this guy is, and that will tell you how much
Yeah.
He's like, oh shit. But he didn't.
Well, from year to year, we had revenue, right? But we didn't have profit. Which is to say,
I would
we're,
try.
we're taking money from the customer, right? But if I pay $1,000 for a lemonade stand, and I sell you one lemonade
Walking on
for $1, how much money do I
I'm
make?
supposed to hit legs today, but we'll see if I actually do it or not. I'm gonna go look at them.
My legs right now, it's like, getting out of my chair.
I mean, it's probably
Last class, I was like, I had to like go.
if I get
Rocking
$1,000,
started. It was so bad.
and then I get
It
paid
looked like
$1,
a baby deer trying to walk around. It's actually terrible.
that, right? So I gotta sell more lemonades to represent moving rightwards on this graph. Moving rightwards means I'm selling lemonade. Moving upwards means I'm making money. Makes sense. The more I sell, the more money I get. But I initially start below zero. Right? So this is like my bank account going from 0 to 999, 500, 0. Because then I make my first dollar. Okay. You know what the difference between marginal revenue and revenue? Or you, Joe? Yeah, it is. That's exactly what it is. Yeah, marginal revenue is 50, and marginal cost is 4. Why? Because cost, $4 per job, right? That's a variable cost, not a fixed cost. Right? Okay. Yeah, looks good to me. See, okay, this is a question of whether we're talking about our cost as an amount of money. An amount of money is positive by nature. You know, when we're talking about our profit, though, we're gonna subtract it. So we want it to initially be positive, so that when we subtract it from our revenue, we're taking away something, right? If we make the cost negative and then we subtract it, we'd be adding, right? Okay, is that what you- Okay. Wait, sorry.
I do too, but if it's wrong.
Right. Go ahead.
12,000 plus 4,000 subtraction of those two.
So the same thing would be negative 12,000 plus 46 cube.
So,
Basically the same thing. 12,000 plus 46.
okay, so we're here. Okay, so our cost, right, initially is $12,000. Is that a one-time payment or a recurring payment? Yeah, one time, because we could buy the lawnmower, then we got the lawnmower, right? And then we also have a recurring payment, which is each lawn that I mow, I gotta pay $4 for gas, right?
Yeah.
So in addition to the cost of $12,000, I have to add to this $4, but not just $4, because I'm not just mowing one lawn. How many lawns am I mowing?
Well,
It's
that's probably
a variable, right?
It's
I mow a few lawns.
It's also like the same.
And then what's my revenue? Well, for each lawn I mow, I get paid $50.
No, we
So
didn't.
our revenue
I
is
bet you
50
didn't.
times.
We didn't have 400 watermelons in this backpack or something, like.
No, so I'm just doing 50 times Q. Sorry, job.
But also
50 times Q, which says that for however many lawns I mow, if I mow
Yeah, like,
5 lawns, I'm gonna do
like-
50 times 5. That's how much money I need. But my profit
just him.
is
Like a
gonna
lawnmower.
be determined by the development. Yes, I collected $50 from 5 people, but I also paid
No, I know.
$12,000 for a lawnmower
Yeah,
and
he's
paid
got the Bugatti mower.
$20 for gas. So I gotta do revenue minus my cost. So in this case, I gotta do 50 minus, and I gotta be careful here with my parentheses, right? Subtract the cost. 12,000 plus 4Q, and I'll get 46Q minus 12,000. Okay, how about the margin? But we don't, that's the thing, is, this is supposed to describe, we're trying to come up with a function, right? So I wanna have a function such that you tell me how many lawns I mow. I tell you how much money I make. And we wanna have the function so that you, as a person, can say, how about 1,000? If you mow 1,000 lawns, how much?
All right, so I saw a lot of good thoughts going on out there. Good job. I think it's really important for you to get your hands on these things and try them in class because it's a little bit different seeing me do it than it is to doing it yourselves, right? Okay, so if you have questions while I'm coming around on group work, just make sure you raise your hand so I can come over and give you all some attention. Okay, so Ted wants to start up a lawn care business. It costs $12,000 to buy all the lawn equipment. Is that a fixed cost or a variable cost?
Fixed.
Fixed. Why fixed? Yeah, because I don't need to buy a new lawnmower every time I mow a lawn. Right? I just buy the one lawnmower and I use it every time. Okay? So that's a fixed cost. Do we have a variable cost? Yeah, what's the variable cost? $4. And why do I have to pay $4? For gas and maintenance. Okay, so that's our variable cost. So the cost function is, of course, built of the fixed and the variable costs. So what's it going to look like? Well, I paid the $12,000 once. How many times do I pay $4? For each job. And how many jobs do I do? Q. It's an unknown, okay? We want to come up with a function here so that we can plug in any amount of lawns and get the cost of mowing that many lawns. So I'm going to do 4 times Q. All right, how about the revenue? Well, I make $50 per job, so 50 times Q. And then, of course, the profit. How do I get the profit? Yeah, I'm going to subtract the cost function from the revenue function. So one question that I had a few people ask is, should the cost function, shouldn't this be a negative number? Can someone explain why the cost function is not a negative number? Alex? Yes, it's an amount of how much I'm paying, which we measure as a positive number.
Yeah, it's like an additional charge to the 12,000 that you already paid.
Mm-hmm. But specifically, how do I get the profit function? I take the revenue function, then I do what?
Subtract.
I subtract the costs. So the costs should be a positive number so that when I subtract it from my revenue, my profit goes down, right? More costs equals less profits, right? So the profit is R of Q minus C of Q. So the cost function describes to me how much I need to pay. And when I'm figuring how much I earned, I'm going to take how much I charged the customer minus how much I paid. Okay, and that way the number goes down. All right, so when we do that, we get, what, 46Q minus 12,000. Great. Okay, so I already answered C. How about B, marginal revenue and marginal cost? What are those? In words, what is marginal cost, profit, revenue? All of that stuff. Yeah, Aiden?
The revenue and cost per unit.
Good. Revenue or cost per unit. For now, we'll have a more nuanced definition of marginal revenue and cost later. But for now, it's the price per unit, basically. For me, my marginal cost is going to be $4. It's cost me $4 to buy the gas to mow one lawn. What's my marginal revenue?
50.
50. And therefore, what is my marginal profit?
46.
Good. Finally, what does it mean if I break even? I, as a business owner, break even. How much money did I make? Zero. Does that mean I have zero revenue?
Zero profit.
No, it means I have zero profit. So there's two ways of thinking about break-even quantity. You can say one of these two things. You can say either my revenue is equal to my costs, or you can say that my profit should be how much?
0.
Zero. Okay, two ways of thinking about it. Either your profit's zero or your revenue is the same as your cost. Okay, regardless, you're going to get the same equation. Okay, let me show you. R equals C would give us what? 50Q equals 12,000 plus 4Q. Or we can write 46Q minus 12,000 equals 0. These two equations, although they look different, they're the same, right? I can make one into the other. If I just take these two over to the other side by subtracting, right? Then I get this equation, right? So two different ways of viewing the same thing. And to solve this, all I need to do is get Q by itself. So I get 12,000 over 46. Did somebody do it? Sorry, say it again. 260.87. Everyone get the same thing? Okay. Any questions on this one? We got some marginal profit, revenue, cost. Yeah.
When it comes to the break-even quantity, like since it's a job and you can't do 260.87 jobs, like do you round up or do you just leave it?
Yeah, that's an excellent question. Usually we want the first item which gets us past 0. So in this case, probably the most correct answer would be to say 261 lawns or something like that would be what you should mow. Because if you mow 260, you're still in the red a little bit, right? If you mow 261, you'll be just over green. Because yeah, you're right. You can't really. Well, I mean, I suppose you could mow 87% of a lawn, but I don't think your customer would be very happy. And I doubt that they would agree to paying you 87% of the cost. Okay. Any other questions on this one? All right. Let's move on to something else. Okay, so problem 3 you can do at home on your own time if you want. I do want to talk a little bit about supply and demand. And there's something which I don't like about this book regarding supply and demand graphs, which is to say that I am not going to ask you any questions about supply and demand graphs. The only thing I will ask you about supply and demand will be for you to find the equilibrium price. Okay, will be for you to find the equilibrium price. So let's talk about what supply and demand are. They are functions, and you're going to notice something immediately different about these functions. To do that, let's go back up to our definition of revenue, cost, and profit. What is the independent variable in each of these functions? Q, which represents what? A quantity of goods. Okay, quantity of goods. When we look at the supply and demand functions, what's the independent variable? P, the price. Okay, so rather than talking about the amount of money we're going to make or the costs we're going to have based on how many items we sell, for supply and demand, we're going to say, you tell me the price, and I will tell you the number of items that a producer is willing to make. Okay? Willing to make. So I, as a producer, if I know that an item can be sold for a lot of money, that makes me as the producer want to sell more of them. Right? I want to sell more items because I'm enticed to sell it. I can sell it for a lot of money. Therefore, I can make a lot of money. Okay? How about demand? What's going to happen to the demand for a product if the price goes up? Yeah, demand is going to decrease, right? Okay, so supply, probably going to go up, right? Demand, probably going to go down over time, right? As price increases. All right, so these are the supply and demand functions. And the equilibrium price, P star, is the price so that, well, what do you think the equilibrium price is going to be? Yeah, that's when Ashlyn said it. It's when the supply is going to equal the demand. Okay, that's the equilibrium. The price so that QS of P equals to QD of P. All right? Great. Any questions on supply and demand and equilibrium price before we see an example? All right. So let's do a quick example. All right. Anna Marie's love of dogs inspired her to create the perfect dog biscuit and start up a business to share them with the world. So, through market research, she found that at a price of $5, she was able to sell 10,100 biscuits. Right? But each decrease in price of 50 cents increased the amount of biscuits which people on the whole wanted to buy, right? Collectively wanted to buy. So we could make a graph of what this looks like in the following way. And I told you I'm not going to ask you to care about graphs, but I'm going to do one anyways to see what's going on here and just visualize it. So if we make the price to be $5, then we sell 10,100 biscuits. If I decrease the price to $4.50, how many biscuits am I going to sell? Well, it says decreasing the price by 50 cents will make us sell 2,772 more biscuits. Exactly. So we're going to sell more biscuits if there's a lower price. It's going to be like 12,872 versus 10,100. This is 5, comma, that, and this is 450, 4.5, comma, that. Okay, so what we're supposed to do is come up with a equation of a line, right? Assuming that this relationship is linear, what is the demand function Q in terms of the price P? Well, we know that Q is going to be a function of P, and we know that the function is linear. So what is the form going to be? Yeah, or in this case, it's going to be MP plus B, right? What was the other form of a line that we had? We have slope-intercept written here, but there was another one we had called point-slope form. Anyone remember what that one looked like? Want to try for it? Noah?
Y minus y1 equals m parentheses x minus x1.
Good, except in our case, we've got Q and P. So which one goes where?
P is one place for M, and Q is.
Well, I think P is going to be our new independent variable. So what was our independent variable before? Or with our y and x, the independent variable is x. So we're going to put a P wherever we see an x. And likewise, for the output, we're going to put a Q wherever we see a y. Does that make sense? Okay, so I'm going to replace this equation by this one. Q minus Q naught equals M times P minus P naught. Okay, so which one is more appealing to you? Just wondering. Total opinion question. Which equation is more appealing to you and why?
The second one, 'cause it's easier to work.
Second one because it's easier, sorry, what? Easier to work with. I would be inclined to agree with that the second equation is easier to work with for this problem. Anybody like the first one better? You can give an answer why. Yeah, Braden?
I've known how to do it longer.
Yeah, that's usually what I hear. People like MP plus B because they've been doing slope-intercept form since they were younger, and it's usually taught more frequently, easier to remember. Okay, whatever. Use what you want. I like the second one, and here's why. For this one, it's much easier if you know what B is. But we don't know what B is. We know that this line looks like this. I could trace it back all the way to 0, right? But that would take a lot of work for me. It's easier to me to do the following. I have to find the slope either way. I can do it easily by just taking the difference in height between these two, which we know is 2772, and we divide that by the difference in width, which is 0.5. My God, someone do this for me on the calculator. 2,772 times 2. It's like 5,300 and...
5,544.
Okay.
Okay.
Okay, we'll trust you. So sorry, what?
500? 5,500.
5,544? Thank you. Okay, great. So that's our slope, right? That's M. And then I can just go ahead and plug it right into this equation by taking Q minus, I'm going to pick this point as my Q naught. So Q naught should be 5. No, Q naught should be whatever the output is, which is 10,100. And then equals to 5,544 times P minus 5. Great. And now you can just leave it like that. So that's why I like that. I don't have to go worrying about trying to figure out what the y-intercept is, or the vertical intercept, right? I don't have to figure out the vertical intercept. I just have to plug into this formula. Okay, but if you don't remember the formula, you can always go back and try to find the intercepts. All right, any questions on that one? Okay. There's two other things I want to talk about this. Actually, just one other thing probably that I want to talk about with this. And that is that if you know what the demand is for a given product at a given price, you can forecast what your revenue is, because I know both things. I know how much I'm going to charge for the product, and I know how many products everyone's going to buy. Right? If I take the price of my product and multiply that with the number of products that I sell, that'll tell me how much revenue I had, right? How much revenue I had. So anytime that you know the equation for Q, as a function of p, which we could get by writing 5544 times p minus 5 plus 10,100. And we know that the revenue can be written as the product of the price with the quantity of goods sold. I can write p times 5544 times p minus 5 plus 10,100 to come up with an equation for the revenue I will make based on the price that I charge. Okay, so this is kind of like a composition, basically, a composition of functions. The price informs the quantity of goods sold, which informs the revenue. Okay, it's kind of like a system where it's like you could say, look, how far I drive depends on how much gas I used. How much gas I used depends on how much I put my foot to the floor in the car. Therefore, how far I drive depends on, through this sequence of relations, how much I put my foot to the floor, right? Okay, so one thing depends on another, depends on another. They transitively depend on each other, okay? So what I want you to remember here is just this formula. Revenue is the price times the quantity of goods sold. Yeah? All right. That's all I wanted to talk about with that. And I'm going slower than I had hoped. Gonna have time to talk about this. Okay, we're gonna do a quick group exercise. All right, so here they give us the supply curve, QS. They give us the demand curve, QD. And they ask us a couple of questions here. Okay, we want to know what quantity consumers are willing to buy at a given price, what quantity producers are willing to supply. We want to know what is the equilibrium price, and what is the equilibrium quantity. All right. So let's get to it in our groups, and I'll be floating around.
Nice, so those is one.
Yes. So the price is gonna go up. Because the demand is high, supply is low. Right? I feel like my AP macroeconomics teacher pretty proud of me for that.
Yeah, look at you go.
So it's to say, if we charge $10, producers think it's worth it to them to make about 600. That could depend on a few things like price of them, make a guide, the price of things around.
I hope this isn't like the car right now.
Equilibrium price is 30.
Okay, let's go back.
Oh, that's the supply.
No way. Dude, I literally am having the worst trouble spelling equilibrium. My brain won't allow me to do it. And put 2 Q's like 3 times in a row. Jesus
Those are you added, yeah. So yeah, 1105. You drink my Alright, so, which is the price at which the demand agrees with supply. Now we're asking, what is that? What is that supply? Okay, so we're gonna plug in 30 here, or if you want here, we're gonna say that's right.
I don't know if I can survive.
But yes, okay, so that's.
No, you're right.
Would anyone like a little bit more time to work on this one? Okay, take about another 1 minute, okay? What are we doing here in the front? This looks promising. On the right track. That's gonna give us the equilibrium price. Are you all good too?
I have no idea.
No idea? Okay.
Really, what was this important?
Yeah, I feel like we're supposed to do this.
Oh, I see. You have it set on like left to right? Oh my god.
Yeah.
Alright,
Different words
anyways.
and symbols.
So,
Different meaning.
Yeah.
this looks good.
It's still the same.
Equilibrium price. I'm a little confused.
I don't know.
Oh, I see. Okay.
Yeah.
So what we want to do here, right, is just set these two equations equal to each other. I think you might have miscopied one of them. 33,000 minus 500 feet is what should be
Yeah.
here, right? And then to solve that, we're going to add 500 feet
Yeah.
this side and get 1,100 feet, right?
Yeah, I make stupid mistakes.
No, that's okay. I do the same thing. You've seen me on the board, right?
Well, that would be for the.
Are you three over? Okay, one's on the bottom. Alright, so. Okay, of course, I think we want to add 500 feet to this side, right? So. Now we're going 5 minutes to 1. Oh, I think we got it. Right.
Is that how you
So 33, actually 33,000. So is the 0. So then we get 30 as our equilibrium price. That looks good to me. So what was your question? Right. So the whole supply and demand functions, right? What do they tell us? They tell us. Is that your business? Okay. So they tell us, look, you tell me the price. I'm going to plug it into this function and tell you how many items consumers want to buy. So if the price is 10, all we're going to do is put it in for me. So the amount that the producers want to supply, and the price is 10, is 6,000.
Thank you.
Multiplied by 10. Oh, it's 32.
Bless you.
All right, let's come back together and finish this up, and then we'll close for today.
Yeah, baby.
So, if you don't mind, wait to pack up until we finish class. Regarding our supply and demand, right? All we have to do here to find out what is the quantity consumers are willing to buy is just to plug in, right? Just to plug in 10. So QD of 10 is going to be what we get when we plug in 33,000 minus 500 times 10. And QS of 10 is going to be what we get when we do 600 times 10. Okay, now how about equilibrium price? How do I find that?
You set them equal to each other.
Yeah, exactly. We're going to set the quantity at which people want to buy, which is 33,000 minus 500p. We're going to set that equal to 600p. And then if I solve this for p, that's going to give me a price at which the consumers want to buy the same amount as the suppliers want to make, which is kind of ideal for a market, right? So if that happens, I think we get p equals 30, okay? We add 500 to this side, we divide by 1100. All right, what about the equilibrium quantity? What's up with that? I already found the equilibrium price. What is the equilibrium quantity going to be? How am I going to find that? Yeah, so 30 is the price at which the supplier agrees with the consumer. But that is not the same as the quantity of goods which are going to be exchanged. Which is to say, look, if this is the price, the consumers and suppliers agree on the amount, right? But what is that amount? The way we find it is just plug 30 in here or right here, right? I can plug it in on either side because that's the whole thing. We found out that if you plug in 30, the left-hand side is going to be the same as the right-hand side. But what those two sides are, that's the equilibrium quantity. And the price which achieves that is $30. Okay? Any questions on this example? Yeah, Alex? Say that again, sorry?
It says, will the market purchase price up or down? Right?
Yes. So if the price is currently $10, right, you can see that if you work this out, what are you going to get? You're going to get the demand is way higher than the supply. That is going to drive the price up, right? Because the suppliers can just increase the price because there's enough demand that people will buy it. Yeah. All right, let's close there for today. Don't forget you have a quiz on Thursday.